Hi, and welcome to this talk about the relevance and applicability of hardware-independent pointing transfer functions. I am Damien Masson, a PhD student at the University of Waterloo, and this work was led by Haïza Hanada in collaboration with Géry Cazier, Mathieu Nancel, and Sylvain Lamalacria from the Lockyer Research Group in Lille. Let me start with some context on the relationship between motor input speed and the on-screen cursor speed. First, a device, typically a mouse or a touchpad, senses a physical displacement, measures it using counts, and sends this value to the computer. The computer then uses what is called a transfer function to convert these counts to a value in pixels. Then, this pixel value is used to move the cursor on screen. All major operating systems work this way, and they often allow users to control the parameters of this transfer function through a simple acceleration settings. However, one problem with this approach is that the transfer function is defined using virtual units like pixels and mouse counts. As a result, the same pointing transfer function can produce different pointer behaviors when used with input or output devices that have different resolutions. In other words, a user may experience different pointer behaviors when switching from one computer setup to another, even when they are configured to the same acceleration setting. In the rest of this presentation, I will refer to this behavior as hardware-dependent. This can happen frequently, for example, when alternating between a home setup and a work setup, or simply when using several monitors with different pixel densities. These situations can require the user to constantly readapt to the system configuration, possibly impacting performance and usability. This also has implications for HEI research. For example, two distinct studies that report having used the same acceleration setting might end up comparing a very different pointer behaviors and infer erroneous conclusions from it. In other words, the combination of transfer function and hardware can be a confounding variable in any experiment that involves controlling a cursor. For all these reasons, in this project, we investigated two questions. We know that different hardware configurations yield different pointer behavior, but does it significantly impact pointing performance? And can we make transfer functions behave consistently across hardware configurations? We investigated the first question in a controlled experiment to test the impact of small differences in hardware on user performance and subjective ratings in pointing tasks. We asked participants to complete a pointing task as quickly and accurately as possible. The targets were of different sizes and positioned along a circle. We also tested 8 different transfer functions, 4 from Microsoft Windows and 4 from macOS. 32 participants took part in the study and was split into two groups. In both groups, participants did the same study, although the input and output resolutions of the hardware used in Group A was different from Group B, but, as you can see on the slide, not by a lot. When looking at the results, we found that the movement time evolved differently when the transfer function changed. A downward trend for Group A, and an upward trend for Group B. We also found that the hardware configuration had a significant effect for 5 out of the 8 transfer functions tested. This means that even small hardware differences can affect performance when using hardware-dependent transfer functions, and it further motivates the use of hardware-independent transfer functions. So, coming back to our research questions, we now investigate how to create and use hardware-independent functions that behave consistently across hardware configurations. To do so, we propose two methods. The first one works by scaling the transfer function so that it matches the transfer function from a reference setup, even if it means losing precision. It consists in a rather simple sequence of unit conversions. Please refer to the paper for details. The second method consists in selecting the built-in transfer function setting that will produce, from a user perspective, the closest physical and visual behavior. While it is not as precise, this method has the advantage of being more practical for end users, as they can apply it right away and without having to run software in the background. To get the closest functions, we asked 4 authors of this work to act as subjective assessors. They were asked to assess which acceleration setting felt closest to the behavior on the reference hardware. For this assessment, we only considered transfer functions on Windows, and assessors could alternate between the reference hardware setup and the target setup. We then aggregated the selections of all assessors, which were highly consistent. In a second study, we evaluated our two methods and the feasibility of hardware-independent functions. 16 participants were tasked to complete a 1D reciprocal task as quickly and accurately as possible. We varied the hardware configuration used and tested both the scaled and closest method. Looking at the results, we found no significant effect of the transfer function on completion time, nor error rate or target reentry. Interestingly, the largest difference for movement time was in a closest condition wherein the subjective assessors would have preferred a setting higher than the highest available. This is a first hint that the closest and scaled methods both provide suitable surrogate functions to replicate an existing cursor behavior across hardware configurations. To support a partial generalization of the closest method, we decided to investigate objective measures of similarity that could replace the subjective assessors. We considered 4 metrics. And when comparing the results with the assessor's choices, we found that the area between two curves yields very similar results with only one disagreement with the assessors. As such, we tentatively proposed that the area between two curves could be used as an indicator of transfer function similarity. However, we only tested the metric on a few hardware settings and only for transfer functions on Windows, so it is too early to advertise this as a bulletproof selection method. Finally, we made 2 web-based tools out of the 2 methods that we are proposing. With the first tool, an HAI researcher will be able to specify the hardware used in a study and reproduce the transfer function that was used in the experiment, even if the specific hardware used is not available. With the second tool, end users will be able to configure 2 different computers with relatively similar pointing transfer functions by only using pointer settings available on their operating system. As a takeaway message, we encourage operating system designers and developers to consider revisiting the management of transfer functions. Transfer functions should be able to adapt to the characteristics of input and output devices, for example, providing more precision when the mouse or screen allows for it, but without sacrificing the general behavior of the cursor. We also encourage computer mouse manufacturers to follow the HID specification that allows specifying the device resolution in the HID descriptor to make it readily available to the operating system. Lastly, make sure to report all necessary information, such as the transfer function and hardware configuration, when describing an experiment that involves controlling a cursor, and take these parameters into account when replicating the study. That's the end of this talk. Thank you for your attention, and feel free to check out the research paper for more details.